exercise, especially intense aerobic exercise, is good for the brain, but we don't necessarily know why. So we propose a mechanism by which this protein, a neurotrophic factor called brain-derived neurotrophic factor, is upregulated, especially with short bouts of intense exercise. And our hypothesis is that if you regularly increase this neurotrophic factor in your brain, you'll promote an environment within your brain that is better for brain aging. So that's how we kind of, that's the model that we propose. We've really just shown that a single bout of intense exercise can increase the concentration of this protein by quite a bit. If you activate a nerve, there will be a signal that's sent along an axon, and BDNF plays a role in facilitating that signal so that less of an active potential is required to get the signal. So BDNF is kind of, some people have referred to it as a fertilizer for the brain, in that it helps growth. It protects against degeneration, neuronal loss, makes you a bit more resilient, your brain a bit more resilient to stress. So it has broad actions within the brain, but generally they seem to be quite positive in terms of learning, memory, and cognitive aging. Neurodegenerative disorders would benefit from an upregulation of BDNF, we think. So Alzheimer's disease, any type of dementia, Parkinson's disease, diseases like that, where there's a neurodegenerative component, I would guess would benefit from regular exercise and episodically increasing BDNF. In this situation, what we studied, because we directly compared long duration exercise up to 2 hours, but low intensity versus just a very brief 6-minute bout of high intensity exercise. So in terms of BDNF release in the brain, we found that the short duration high intensity was better. And the reason we propose is because high intensity exercise increases your circulating lactate. So if you're working really hard, you produce a lot of lactate in the muscle, and that lactate is delivered to the brain, and the brain can use that as a fuel. So what we think is that when you force the brain to use an alternative fuel, lactate, this upregulates some of these processes that ends up with more BDNF being produced and released into the blood.